Hi guys, this is Vidur. I'm a senior system engineer in Juniper Networks for Mist Wireless, and today we will do a quick Mist demo. Okay, so this is the Mist dashboard, and this is the home page, as we all know. Uh, Getting right on it. So before this entire dashboard was built, and the concept of SLEs came in the picture. There was a quick survey that was done, to understand the 10 problems that people face in the Wi-Fi world nowadays. So a lot of people took part in the survey. There were network admins, network operations managers, and then IT guys, end users. All of them took part and answered the questions, and we got a lot of answers telling us which all problems they face in the Wi-Fi network. But there was this guy from South Africa who gave a very crisp answer to our question. He said, I do not face 10 problems in my Wi-Fi network. I have only two problems. One, I cannot connect on the Wi-Fi. The second, if I'm able to connect on the Wi-Fi, my Wi-Fi sucks. My Wi-Fi is really bad, which means I'm not able to pass traffic at good throughput, right? So these two problems are the main problems. Everything else will lie in these two issues or in these two problems. So we created these SLEs based on these two problems of pre-connection and post-connection metrics. So the first three SLEs are, I cannot connect on the Wi-Fi, and the next four are, my Wi-Fi is really bad. So trying to understand the user experience on the ground is what we thrive on, what we want to do, because nowadays even if the APs are up and running, that is not the same as good. We want the users on the ground to have a great time, and that's why we defined these SLEs. So what time to connect SLE will tell you is how much time the client is taking to get on the internet, whether and successful connects basically will tell you if the client is anyway able to get on the internet fine or not. Roaming will tell you if the client was able to roam properly within the specified time or not. Coverage will tell you if the client has enough RSSI value, or if the client has enough coverage to send traffic, if the client has good throughput, if the client has enough channel to send out traffic, and if of course the AP is up and running at all times. So we capture all these things from the client's perspective and tell you whether the client on the ground, which is connected on the Wi-Fi, is having a good time or not. Now, for us to take control, we give you an option to specify that value. Now, for example, if I click on settings here, I can quickly tell myself, for my network, the goal is 2 seconds for everybody to get on the internet. This can vary depending on the kind of network that you're running. You may want to have it in 3 seconds, 2.5 seconds. That's totally up to you. So you can drag the ball here and then change the value to whatever you like. Similar to then roaming, you define a value for roaming. Everybody you want to roam, you want people to roam in 2.2 seconds. That's your goal. Coverage, you want to have a specified coverage goal here as well. So any client that passes, that will pass this goal will be marked as a positive in the SLEs. Any client which is not passing or which is failing will be marked as a negative in this SLEs. Now, for example, let's see if currently in this particular deployment, I see time to connect SLE not being met very well. I see only 62% successful people. By the way, guys, this is the live demo site. This is the site that is built in the office of Cupertino in Mist, and this is a test environment. So you will see some number here. Why? But this is actually good enough for us to demo and see how things really are in the real network. Time to connect. Let's say my network is only passing 62%. So 62% of the clients are able to go onto the internet within the specified time of 2 seconds. That was my goal, which I defined in the settings tab here, right? So let's see. The SLEs are time to connect, but I have four classifiers, which means if my client is not able to go on to the internet within the 2 seconds, it could be because of association problem, authorization problem, internet services, or DSCP issues. It cannot be the fifth. It cannot be any other one, right? So I see the 38% lost here are mostly due to association problem. So I'm going to click on association and see where it takes me. It's going to take me to the second page, and these are the SLE metrics. I see some classifiers here as well. Time to connect, and association is causing the problem. Now, if you run into a problem, what will you do? You will bring up a tag case. If somebody complains on the ground, you'll bring up a tag case. You'll try to solve that problem. TAC will come back to you and ask you 10 questions, like where exactly did the issue happen, which AP got affected, which client got affected, when was the issue seen, All those questions the TAC is going to ask you, which is standard protocol. They want to get more out of you about the network so that they can reduce and give you the answer, right, of the problem. Now this page is doing that for you. You don't need to go back to TAC, and TAC has to ask you questions, and then you're going to take 2 days to get all the answers and then reach out to TAC and give the answers. This page will do that for you. So now this page will tell me what was the timeline of my issue, what was the distribution of my issue, who all got affected, whether which access point got affected, which wireless band got affected, what are the device types that got affected, which OS the devices were running that got affected, and also which SSID got affected. Now that this is actually narrowing down for you to the most affected items. Of course, you can actually figure out which user got affected, which access point got affected, and which applications that they're running also got affected, right? That's really huge, because now it's going to save you 2 days of time, and you don't have to really go back to TAC and after 2 days and give all the answers. You will have all the answers here in no time, and then you can find out the answers and again give this to TAC, or what they can do is they can actually just look into your organization and get all the answers immediately. Okay. Now, for example, Denali is one of the clients that I see. Let's say Denali called me up and said, you know what, I'm having a bad time on the Wi-Fi. I need you to figure out what that really is, what the problem is. So let me click on Denali and see what happens. Once I click on Denali, I can see a View Insights tab here. I'll click on View Insights, and now what I did was I actually entered into the device of Denali. Now this page will tell you all the client events that Denali went through in the last 7 days. Okay. As I said, when the client gets onboarded or comes in contact with an access point, it goes through layer 1 auth, then association, then layer 2 auth, then DSCP, then gets the DNS, hits the and then hits the gateway and goes out to the internet. But a wireless client can go to can go through 150 different states in the Wi-Fi network. This is where I got it from. I click on the hamburger icon here, I click on it, and then this page pops up. So all these events are actually captured by the MIST system or captured by the MIST access point, and we understand all the events that the client can go through, whether they're good events, neutral events, or bad events. We are able to capture them on the screen for you. Now Denali has had a bad time. Let's see what's really going on. I see some DSCP timeout issues. I see some auth failures. It would start from this data would be for last 7 days, and now let me give you an example. Now if your client if you have deployed a wireless network and one of your client fails a roam, while you're walking, while the client is walking from one area to the other or one AP to the other, the client is on a voice call and the client drops a voice call. You bring up a TAC case, you tell TAC, there was a voice call drop and I need you to figure out what the problem was. TAC will come back and tell you, okay, that's okay, but we want the wireless packet captures to figure out, what really happened in the call and why was it dropped. Okay. Now imagine yourself doing this. You are actually you have two laptops in your hands. Okay, both are running Wireshark, and you are basically initiating a voice call from one laptop to the other laptop, and you're walking from one AP to the other AP, and hoping to capture the traffic and hoping that the voice call drops and you're able to catch the problem in the wireless packet capture. Now this is very tedious. This is not something which you should be doing, and if you're lucky you'll probably be able to capture this issue in 3 or 4 attempts. But with every bad event that happens in the MIST world, every bad event that happens on the client in the MIST world, we will take a dynamic packet capture for you. Okay. Now this is something which you need to understand. Every bad event the client goes through in the MIST world, a dynamic packet capture will be taken automatically. You don't have to go back, you don't have to recreate the problem on the ground, you don't have to spend 2 days to do that. You already have it ready. You just need to click on it, get the packet captures and send it to TAC for further investigation. Right now this is done by MIST only at the moment. There is no other vendor right now who can do dynamic packet capture for you. Now this will save a lot of time for troubleshooting. This will save a lot of time for people running a wireless network and who run into a problem. The reason why I gave an example of roaming is because roaming is the most common problem in today's wireless network, and probably the most critical and then the most difficult to troubleshoot. and it takes a lot of time for people to gather wireless captures, and then they go back to TAG, and then they analyze, and then they come back and tell us, you know what, these captures are no good because I did not see an issue there. So instead of doing all those things, you have a packet capture ready for you, and you can just click on it, and life is good, and you can send it to TAG and for further investigation. So SLEs and packet captures, right? Next, what we're going to discuss is Marvis. Marvis is our AI engine that works on natural language processing. Marvis is the virtual network assistant which will get data in real time from the network and answer questions for us. Now, for example, I'm going to use this thing. I'm going to use this time to give you an example about Marvis. Now, for example, if one of my person sitting on the reception, he or she has no idea about wireless, he or she has no idea about technology, he's just there to receive calls and get complaints, and hand it over to you. Now, you do not want, as a network manager, you would not want every small thing to come to you. So now for example, if Denali had called the guy sitting at the reception, complaining that he's having a bad time, he's not able to get on the internet just fine, so you might want to look into it. So what the person at the reception can do is this. So I can write troubleshoot Denali, it's already there, so I'll click enter. Now what Marvis did was, Marvis converted that simple English language into its query language for it to understand. Let me zoom in. Yeah, it converted simple English language into query language, and then I can change it to last 7 days so that I get some good data. Hit enter, and then it gave us result on on the data it fetched from the network. Okay, it says what, overall looks okay. Seems to be some slowness in the network. I see a slow association. This problem is widespread at live demo, at the live demo site, and this is on this access point, and this is a pretty good one-line summary of what the client is going through, right? This is a pretty good one-line summary. So Marvis is our AI engine which will run the algorithm at the backend and give you this summary. And further, what the receptionist can do is click on investigate. Yes, I want to do that, and then I can go in the client events and see what the client is going through. Okay, I'm back to the same page. I can click on the bad events, and I do see there's a DSCP timeout, an auth failure, multiple auth failures here, and I'm good with it, and with the packet capture. Now, instead of you having to find that out, the receptionist can actually click on download packet capture, and can give you the packet capture, and you can further send it to TAG for investigation. Now, for someone who had no idea about network, no idea about wireless, was able to do level 1 troubleshooting for you, and give you the relevant result. Now, that's the power of Marvis. I can also do, this is just one thing what you can do with Marvis. I can also go ahead and I can write what are the unhappy users in my network. So any user who's not able to pass the SLE, just I want to know about them. So what it did was, it converted that unhappy user into a query language. I'm going to change it to last 7 days where I get good data. Again, it converted that into a query language for it to understand, and then gave you a result after fetching details from the network in real time. So all these clients which are having a bad time in the network can be viewed through this. Now, somebody who's going back home on a Friday evening can actually just get this report from Marvis, and come back Monday morning, or and focus on these clients which are having a bad time, and try to talk to them and understand what really is going on. So this is the proactive approach of you trying to troubleshoot issues. Another thing that you can do from Marvis is let's see, list. I'm sorry, before I forget, so there's one more thing that I want you to look at. I will use this command right now. So if I want to locate a wireless client, I don't know where the client is, and I can just type locate Denali, hit enter. It's going to locate Denali for me in the map that I've already uploaded and added to the location tab here. So here is Denali, right? So it actually used the intelligence at the backend and actually told me where Denali was located at that time. That's what Marvis can do. I can write list clients, and it will give me all the list of clients in the last 30 days, and all the good stuff. Now, one more piece of the puzzle is Marvis actions. I'm gonna. This is what Marvis action. This is where Marvis action is. Uh, Here it is, Marvis action. I'll click on it. Now, this is special because Marvis action. Now, for example, if you run into a problem, you bring up a TAC case, and TAC will ask you some questions. You will go back and give them the answers. TAC will analyze, and give you some steps to execute, or changes to make on the GUI, and you will make the changes and then probably fix the issue. Now, Marvis action will take you from step number one to step number last. Okay. Marvis action can do a lot more things for you. Marvis action can this is more like a coffee cup view. When you come back come to office Monday morning, you can sit and with a cup of coffee in your hand and check what issues are there in your network as a whole. This is the org view. Okay, this is the org view here. If you see, this is the entire org view. I see 7 main issues, which are 3 connected to switch, 1 is the AP issue, 2 auth issues, 1 DSCP DNS issue, right? So let's see what the switch issues are really in our network. I see something called a missing VLAN. Now, for example, if you have a network of 1000 APs, okay, and you have 3 SSIDs configured on those 1000 APs. So practically what you're doing is you are configuring 1000 switch ports with 3 VLANs each. Right, that's what you're doing to pass to broadcast 3 SSIDs on 1000 APs. Right now, for example, now it's very much possible that by simple human error you forgot to add 1 or 2 VLANs on a couple of switch ports. It's possible. Now, what will happen on the ground is if anybody if a user walks in, I walk into an office premises and I see 2-3 APs in my vicinity. I connect, I see the SSID, I try to connect on it, but my traffic will be black hole because there is no VLAN on the LAN side. I'll get slightly frustrated. I'll see, I don't know what's going on. So let me disconnect and try and connect once again. And hopefully I will connect to a different AP now. And I'll be able to pass traffic just fine because that AP has the right VLAN, and I will not even raise that issue. So the user experience on the ground was really bad because I was not able to pass traffic for a while, but then I was able to pass traffic on the other AP just fine. Now, as a user, I will not complain, but it's not a good thing. The issue still exists in my network, right? So when we did a POC for one of the customers, we were able to find in the first phase of during the POC, we had a couple of warehouses or a couple of retail stores, I must say. So we were able to find 2 missing VLANs in the 32 APs that they had deployed in the POC. So which means there were 2 switch ports which were missing a couple of VLANs, on the switch ports. So not only we figure out there was a missing VLAN, we also tell you where exactly is the missing VLAN present and on which switch, on which port and on which switch, and which VLAN is missing. So that is the power of unsupervised machine learning. Okay, so it will monitor the traffic on the AP port and then tell you that what, I see some traffic of the other VLAN on the other port which I should also see here, but I am not able to see it. So that's when it will mark it as a missing VLAN. Now guess what? When we had a first phase of deployment for the customer in retail store, we were able to find 16 missing VLANs for him, which was just outstanding because they never thought this issue even existed in their network. So now this was a needle in a haystack problem, drop in the ocean kind of a problem, which will be there, but you're not able to figure out, if you'll never be able to figure out, from a standard OEM or a standard Wi-Fi or a controller deployment. Okay, the next part is bad cable. Of course, we are also able to tell you which cable in your network has gone bad. For example, if you have, let's say, hundreds of switches and tens of thousands of ports you have deployed, then it's very difficult for you to go and check every port manually. Mist will tell you which cable has gone bad. Mist will tell you which cable to replace, where to look for. And in this scenario, it says this is the switch, this is the cable that has gone bad, and you need to go and check it. Similar for negotiation mismatch, you can actually figure out where is the negotiation mismatch, and more things you can do about it. Now that is something great because Marvis action is the first path, first step towards a self-driving network that Mist is working on. You can also, if there's an ongoing issue in your network, you can also mark it as open, in progress, or resolved. Once you mark the issue as resolved, the AI will validate that for you. Okay, let's say for example you had a missing VLAN and you said, you know what, okay, I think it's resolved, so I'll mark it as resolved. Once you do that, the AI at the back end will validate that for you and then tell you that, you know what, yeah, you were right, it's resolved. If not, it will prompt you once again and tell you that you need to fix this issue and it's not resolved right now. That is Marvis Action for you, which is a game changer in the current network right now. Okay, so let me quickly go to the location tab here. Guys, next is location. This is where we reach location. I'll click on live view. Okay, so this is where you upload a map. I already have a video to upload a map. I will paste the link of that video in the description so that you can figure out and understand more on that. Once I click on the map, I'll be taken to this particular to this live demo, this office map which I've uploaded. Okay, so first and foremost, Mist has 16 antenna for BLE in every AP that we have built, which we use for location tracking, right? And this is the hamburger icon, as you can see on the screen. Once I click on it, I will be shown some more options. Mist is the only platform that shows you all these 5 vectors in a single pane of glass: app clients, Wi-Fi clients, unconnected clients, BLE clients, and assets. App clients are all the clients that are running the Mist SDK. Wi-Fi clients are the clients which are on the Wi-Fi. Unconnected clients are the clients which are probing the network but not really on the network. BLE clients are the clients which are sending out any BLE signal. Could be a phone, could be a headset, could be a smartwatch, anything that's sending out a BLE signal. And anything that is marked as an asset and sending out a BLE signal is marked as, it can be seen under show assets here. Okay, fantastic. Now let me zoom out a bit so that you are able to see it well. Cool. So the next thing I want you to understand is Mist can also use the 16 antenna for BLE for multiple use cases. For example, asset visibility, proximity messaging, and indoor wayfinding, right? These are the 3 use cases that I can discuss right now. Proximity messaging is nothing but, let's say an end user enters a mall, he or she gets a push notification saying, welcome to the mall, 20% discount on Starbucks, 20% discount on US Polo, 30% discount on Tommy Hilfiger, or another push message saying, flash sale, there's a bumper offer, Christmas sale going on at this particular shop. All the good stuff can be pushed out to your mobile phone through that beacon that is deployed on the wall. So now that ideally can be done in 2 ways. One is through a battery operated discrete physical beacon, or what Mist has come up with, a virtual beacon. Virtual beacon is our patent, right? We use the AP's antenna to create a virtual coordinate on the wall, which will act as a beacon for you. Now, instead of buying multiple beacons to cover a mall, multiple physical beacons to cover an airport, or to cover a healthcare department, you do not need to spend any money. You just need to use the virtual beacon technology for Mist, and life becomes good for you. So I'll tell you how we add that. I'll click on virtual and beacons and zones here. Once I do that, I'll click on add a virtual beacon. The moment I clicked on add a virtual beacon, there is this virtual beacon which is displayed. I'll click on it and I will do a quick edit. Let me zoom in again here so that you see where I'm really going. Click edit. I can give the name is this is a demo, message is demo message, and I can select the transmit power as whatever I want and click on save. Okay, now once I click on save here, my beacon will be shown. Now from the hamburger icon here, I can click on show virtual beacon coverage. The moment I do that, I'll be seeing the coverage of my beacon. Let me click on the beacons tab here. This is the demo. This is my beacon that I've created, which you can see, and this is the coverage area of the beacon. Now anybody in the vicinity of this beacon in this area will be pushed a message. This is a demo, or the message that we configured here. Let's see what we configured. We configured demo message. So this message will be pushed out to the clients which are in the vicinity of this beacon. Now for clients to receive this message, they need to have a mobile app running, right? That's that in that app we will be able to push that message from the virtual beacon. That is one use case which is widely deployed right now in multiple sectors, whether it's healthcare, whether it's airports, whether it's retail or warehouses, or all sorts of sectors use this kind of service right now. Second is the asset visibility. That basically means, any asset which is any device in your network which is important for you, which is critical for you, can be stuck on with the BLE tag, and we can constantly check its location using the 16 antenna that we have in the AP. Now in that scenario, the 16 antenna will be in the listening mode. The BLE tag, which is stuck to the asset, will be chirping out BLE signals every sub-second. The APs will be catching that signal and then be able to locate it on the map just fine. I'll click on the assets tab here, and from the hamburger I want to also click on show assets so that I'm able to see the assets. Let me just uncheck the show virtual beacon so that we can clear up the space. And yeah, so I'm going to show I'm going to click on show assets, which will be in the green color. I see one asset right now in the area, which is here at the bottom, right? So any client that is stuck with a BLE tag, or any device, let's say in a healthcare department, you have a computer on wheels, you have X-ray machines, you have all sorts of equipment that you want to preserve. You can stick that with the BLE asset, with the BLE tag, and then that tag will continuously emit BLE signal, which the APs can catch and locate the asset on the ground. That's called asset visibility, in which the APs are really in the receive mode. The next is indoor wayfinding. Okay, indoor wayfinding is nothing but trying to navigate from one area to the other area in the premises. It's like Google Maps, but only indoor, right? So once you enter an airport, you go and collect your boarding pass. Now you want to go to the immigration center. You don't know where the immigration center is. You can bring up the application. You can you can open the map and enter your destination as immigration center. Once you click on OK, a navigation path will be formed for you, trying to help you to reach your destination in the smallest path possible. And there'll be a blue dot on that which will depict your device. So as you move, the blue dot also will move. Now how that works is, as in when you move, you will come in contact with multiple APs on the roof, on which are installed on the ceiling. Now you should have a mobile application. You should have the airport application, which will be integrated with the Mist SDK. Integration with the Mist SDK only mean that we are giving the app the ability to talk to the cloud. That's what it is doing, right? Now when you have the application running on your phone and you are walking, your mobile or your Mist SDK in the application will be listening to the beams coming from the AP. Yes, the APs now will be in the transmit mode. The mobile SDK, the Mist SDK, will be listening to the beams coming from the nearby APs, and the SDK will create an SDK report and send it back to the cloud, letting it know, what, this is the signal at which I hear all these APs. The cloud will calculate the location with the Mist SDK report and push it back to the device as a blue dot. That's how when you move, the blue dot also moves with you. Okay, with Mist deployment, you can have a location of the accuracy of about 1 meter, which is really accurate when you talk about indoor navigation. And that's the third use case which you can accomplish. Of course, there are many other use cases on location that we can actually accomplish, but these three basic use cases are something which are widely deployed right now in all sectors, something that you might want to check in and look at. Fantastic. The next thing that I want you to basically understand and look at from the Mist side is the wired assurance piece of the puzzle. So I'm going to click on switches. So Mist was acquired by Juniper in April 2019, and that was when Mist had the wireless APs, wireless portfolio running on AI and ML. We wanted to make sure that that the switches also very soon are Mistified, which means they also should be able to be managed by the Mist dashboard. They also should have the ability of AI and ML, and I think within 6 months, Wired Assurance 1.0 was launched. So in Wired Assurance, we're just going to spend 5 to 7 minutes on Wired Assurance to understand what that is. Okay, so first of all, when we talk about the concept of SLEs, service level expectations, we saw the SLEs on the wireless side. We also have the same SLEs on the wired side as well. Now we are also trying to understand the user experience on the ground on the wired side as well, if the clients have enough throughput, if the clients are able to successfully connect or not, and what is the switch health, whether it has a, it has a temperature problem, it's a switch unreachable, memory problem, CPU issues, or some power failure or power device failure. Now all these things we are able to basically capture. We are also able to capture if the throughput problem is because of storm control, congestion uplink, congestion problems, network problems, or interface anomalies. I think we are also in the process of bringing out and trying to get the STP loop detection also on the wired side, which is going to come out very soon. And that's how we brought in the concept of SLEs into the into the wired world as well. Now going to the switches tab once again, I will zoom out a bit so that you see it well. Okay, yeah. Now currently all the Juniper switches in the EX portfolio can be managed by the Mist cloud or the Mist dashboard, right? What it means is I can actually have the entire switch managed and configured by the Mist dashboard. Configuration of the switches came in the Wired Assurance 2.0 portfolio. In Wired Assurance 1.0, we only could add and manage devices, monitor devices. So there are two ways to do this. One is there are two ways to add a Juniper switch into the Mist dashboard. One is through LLDP. Now, if an access point is connected onto any switch, whether it's a Cisco switch or an Aruba switch or Juniper switch, it should support LLDP. The APs will be able to fetch information of the switch, and you will be able to see that switch here in gray color. The color would be gray. This is all green and red. The color of that entry would be gray, okay, which means you can only see some specific parameters, not in depth about, in depth or we'll see what I'm talking about in a couple of minutes. But you can only see some basic stuff of those switches. Now on the other hand, the next thing what you can do is you can add or you can adopt a Juniper switch completely in the Mist dashboard, which means if you already have a Juniper switch deployed somewhere, it's a brownfield deployment, you can go in org, you can go in inventory, and in the switches tab you can click on adopt a switch. I'll just zoom in a bit so that you know where I'm clicking. I can click on adopt a switch. Once I do that, I get this set of commands. I can just do a copy. I can select all. I can select all, and I can do a copy to clipboard and go and paste those commands in the switch CLI and hit commit. Commit means you're saving the configuration, right? So once you do that, that particular switch will take, I don't know, very less time to get added to this particular instance, and you will see that switch here in the switch tab. Okay, if you're using a new switch, if it's a brand new switch, the switches now come with ZTP, zero touch provisioning. So they come with the QR code, which you can just scan, and it will be automatically uploaded. Or if you want to have done it through a different way, you can click on claim a switch here. Once you click on claim a switch, I'll zoom in a bit. Once you click on claim switch, it will take us to this page where you can enter the activation code or the claim code of the switches that you've ordered. Let's say you placed a PO of 100 switches. You will get one activation code or one claim code, which you can add here, and then you can do a claim here, and you can add it to whichever site you want to add it to. You can do a claim here, and all those APs will be added in the inventory tab here. You will see them in this section. So now from there on, you can select the AP switches and move it to whichever site you want to move it to, and life would be good. Once you do that, your switches will come and be displayed here. Okay. This is the list view. You can also get a topology view. You can check which this is the site. You will see these switches. Let me click on these switches. You will see further some access points, or you can have, I'll click on this, you will see some more access points. I'll click on this, you will see some more access point switches. Further moving on, you will see some access points, and I think I see 3 clients also on that access point. So yeah, that's how you create a topology view, which is also quite good. Now let me click on one switch and show you what I'm talking about. Okay, I'll choose this switch. Okay, so if my switch is added into the Mist dashboard from the LLDP information, like the first time that I talked about LLDP information, you will only see this information. Okay, you will not see the switch insights here. You will not see this. You will see the front panel. You will see which device connected where. You will see some basic information like the version of the switch, the model number of the switch, and what is the IP address, and yeah, all those things you'll be able to see. But now, since it's a Juniper switch, it is adopted through the adopted method. It's going to also give us the switch insights, which means if I click on switch insights, I'm going to be taken right into the switch, and I'll be able to see all the events the switch went through in the last 7 days. Just like if you remember, we went into Denali and saw the events for the last 7 days. Now we are able to see the switch event for the last 7 days. Okay, perfect. I can actually do a filter and only check events based on per switch port, whichever switch port I want to check the events on. I can select that, and the events on those switch ports will come in. Further moving on the switch on the insights, I can see the CPU utilization spikes, I can see the memory utilization spikes, I can see the port errors, I can see the bytes which have been used, power drawn, I can see the port information and which device is connected where, and I can see the current switch properties, which you anyway saw in the other tab as well, right? So that's the beauty of Wired Assurance 1.0. Okay, now with Wired Assurance 2.0, something more came in the picture. Now if I go on switches once again, Wired Assurance 2.0 gave us the option of completely managing the switch from the Mist dashboard. We are also able to do the exact or the complete configuration of the Juniper switch on the Mist dashboard through the Mist dashboard, and this is only done for Juniper EX switches right now. For the other model of switches, this is currently being worked on, and I think in the first quarter or second quarter, I think that's the timeline, but I'm not sure. Very soon you will see some good announcements around the other model of switches also, which are being managed by the Mist dashboard. Now you are able to completely assign port configuration or radius configuration, dynamic port configuration, which basically mean if I can create different profiles, like I can create profiles like AP profile, cameras profile, or default or IoT profile. Now if I can assign these profiles to specific switch ports. Now if I connect a camera on any port, it should automatically be able to detect that this is a camera and should push the right profile to it. This is called dynamic port profile allocation. This is also done through the Mist dashboard in Wired Assurance 2.0, right? So this is all the good stuff around Wired Assurance 2.0. We have made some great progress around it, and currently we are also working on adding more and more models of switches of Juniper, starting from the distribution and the core switches, the QFX switches also, which will be added very soon and be fully managed by it. All these configuration can not be given to any third party switch, right? This is only given to switches which are adopted or which are claimed in the Mist dashboard, and the only switches which can be claimed and adopted are the Juniper EX switches right now, or the Juniper switches in short. Okay, so what we discussed today was the SLEs. We discussed about dynamic packet captures. We talked about Marvis. We talked about Marvis action. We talked about location and how well Mist does location. We talked about Wired Assurance 1.0. We talked about Wired Assurance 2.0. Very soon we are coming up with WAN Assurance. You see the option for gateway here on the left hand side. You will be able to see, and you'll be able to see SRXs here as well. You'll be able to adopt SRXs. You'll be able to, in fact, you can adopt SRX even right now. You can also do a lot more in the coming time, and we'll talk more about that in the coming videos. But yeah, not in this video for now. Okay, guys, I hope this was helpful. This was the complete Mist demo that you need to know. You need to know to understand more about Mist. If you have any questions around any particular part, let me know. Drop me a message, and I'll be able to address those ASAP. Thank you guys for joining. Do share your comments in the comment section, and your feedback is always welcome. Thank you guys. Hope this was helpful, and you have a wonderful day.